For decades, millions of homeowners have bought riding lawn mowers, believing that routine engine maintenance is all it takes to keep a machine running for 20 years. But behind closed doors in corporate engineering labs, manufacturers made a deliberate design choice that ensures your machine hits a hard expiration date right around the 300-hour mark. That weak point isn't under the hood. It sits hidden right beneath your seat, the integrated hydrostatic transaxle. If you look at older garden tractors from the 1980s and 90s, heavy-duty transmissions were built with external maintenance ports, drain plugs, and heavy fluid reservoirs. They were designed to last generations because owners could flush out metal debris, replace the oil, and keep internal pressures stable. But modern equipment changed the business model. By replacing serviceable units with sealed hydrostatic transaxles, units labeled and treated as entirely non-serviceable, manufacturers created a ticking clock. As the mower operates, microscopic friction creates aluminum wear debris inside the sealed housing. At the same time, the specialized hydraulic fluid breaks down under intense operating heat, losing its viscosity and lubrication properties. Because the system is permanently sealed shut with no factory drain plug, that contaminated oil has nowhere to go. It circulates continuously, grinding down internal pistons, valves, and pump blocks, until the transmission loses prime, fails to climb hills, or completely seizes up. When a homeowner takes a dead mower to a dealership, they aren't told that a simple $30 fluid flush could have saved it. Instead, they are handed a quote for a brand new transmission assembly, costing upwards of $1,200. Or worse, told to scrap the entire machine and buy a replacement. It's an engineered lifespan disguised as convenience, a system designed to fail right on schedule, so the hardware cycle never stops turning. Throughout suburban neighborhoods and municipal landscapes, millions of property managers invest heavily in commercial-grade turf management assets, operating under the assumption that routine spark plug replacements, air filter changes, and regular blade indexing will guarantee 2 decades of reliable service. Yet inside secretive corporate boardrooms and overseas drafting facilities, engineers implement TARs are designed to force catastrophic drivetrain failure, a product of mental health cycles designed to force catastrophic drivetrain. The primary hardware vulnerability does not exist inside the combustion engine or the cutting blades, but is concealed entirely beneath the operator platform within the integrated hydrostatic drive assembly. Historical garden tractors manufactured during previous decades utilized heavy-duty cast housings equipped with external service ports, accessible oil reservoirs, and threaded drain plugs. These legacy configurations allowed field mechanics to flush out microscopic metal burrs, replace degraded fluid, and maintain consistent internal operating pressures. Corporate profit models subsequently shifted toward disposable assembly practices. By substituting serviceable components with permanently sealed transaxles, labeled as maintenance-free, manufacturers established an invisible expiration timer inside every chassis. During continuous operation under heavy turf loads, internal gear friction sheds fine aluminum particulate matter directly into the fluid chamber. Simultaneously, extreme thermal cycling breaks down the molecular structure of the proprietary hydraulic oil, stripping away essential shear resistance. Because the housing lacks any drainage port or filtration medium, this contaminated slurry remains trapped within the system. The abrasive mixture circulates continuously across precision ground valve plates, charging pumps, and motor cylinders, scoring internal metal boundaries until hydraulic pressure drops entirely and the machine loses mobility. When frustrated operators transport disabled equipment to regional service dealerships, technicians rarely disclose that a preventative fluid exchange could have preserved the drivetrain. Instead, owners face prohibitive repair quotations exceeding $1,000 for dual transmission swaps, or pressure to discard the entire platform for a replacement purchase. This phenomenon represents a calculated corporate obsolescence strategy masked as user convenience, a recurring mechanical breakdown engineered to sustain perpetual consumer consumption. Across the globe, industrial economists and municipal fleet operators rely heavily on elite turf management systems, anticipating decades of unfailing mechanical output, backed by basic spark plug maintenance and occasional belt replacements. Behind locked corporate doors, however, multinational equipment conglomerates coordinate proprietary obsolescence protocols designed to ensure residential assemblies suffer catastrophic structural failure precisely when the warranty window closes. The central engineering flaw does not reside within the power plant or the cutting apparatus, but is hidden completely beneath the operator floorboard, inside the sealed hydrostatic drive unit. Vintage tractors manufactured during previous decades featured heavy cast-iron transmission housings equipped with accessible fill ports, external reservoirs, and threaded drain plugs. These serviceable legacy architectures allowed independent mechanics to purge microscopic metal particulates, replace degraded oil, and stabilize hydraulic operating pressures. Modern manufacturing economics eliminated this user access entirely. By replacing serviceable components with permanently sealed transaxles, marketed as maintenance-free, corporate designers established an invisible countdown timer within every chassis. During heavy turf maintenance operations, continuous internal gear friction releases microscopic aluminum filings directly into the fluid cavity. Simultaneously, severe thermal stress destroys the chemical integrity of the proprietary hydraulic oil, stripping away essential boundary lubrication. Because the housing lacks any external drainage mechanism or internal filtration screen, this metallic sludge remains trapped permanently inside the casing. The abrasive slurry circulates relentlessly across precision valve plates, charge pumps, and motor pistons, scoring internal steel boundaries until operating pressure drops completely and the machine loses drive capability. When disappointed operators transport disabled equipment to authorized service centers, technicians rarely explain that a preventive fluid exchange could have preserved the transmission. Instead, owners receive staggering repair estimates exceeding $1,000 for complete dual transaxle replacements, or recommendations to discard the platform entirely and purchase a brand new unit. This practice represents a calculated corporate obsolescence model, disguised as convenience, a systematic mechanical failure engineered to guarantee continuous consumer replacement cycles.